take a second to read that. So this question has a little bit of data. And when you have a little bit of data, sometimes it's nice to organize it in a matrix. So we've got to decide, and what we decide for our first matrix is going to affect what we have to decide for our other matrices. Because if we make budget, economy, executive, and presidential in the columns part, then later on we're going to have to make it in a rows part in order for matrix multiplication to work. So would you like budget, economy, executive, presidential along the top, or you like it down the side? What? Down the side? Okay. Budget, economy, executive, and presidential. This is going to start off with a matrix. So the first information they're giving us is about transistors, capacitors, and connectors. Transistors, capacitors, connectors. And we can fill in the data from this. Budget, 50. Oh, I missed dials? Man. I would have figured that out when I went to dials and had nothing to put it in. Okay. So the budget has 50, 37, and 3. The economy, 65, 50, 9, 4. Executive needs 85, 42, 10, and 6. And finally, presidential, 85, 42, 10, and 12. Daily manufacturing goal in a normal quarter is 10 budget, 12 economy, 11 executive, and 7 presidential. So now I'm going to create another matrix that represents that stuff, but now I'm going to put my matrix this way so that if I do use matrix multiplication, that will match up with the column. The columns and the rows will match up. So we want to make 10, 12, 11, and 7. So put this into your calculator, call this one matrix A and this one matrix B. And from that, since this is a 4 by 4 and this is a 1 by 4, we could multiply these together. How would we multiply? B times A. Can't do A times B. You have to do B times A. And you will get as an answer a 1 by 4. I'll make it bigger. And the 1 stood for per day, and the 4 stands for transistors, capacitors, connectors, and dials. So again, type that into your calculator and push enter, and we'll get the numbers written down. So when we multiply them together, we are basically solving part A. How many transistors are needed each day? Capacitors, connectors, dials. And when we multiply B times A, that's what we get. Because we can see the per day comes from B, and the transistors, connectors, capacitors, and dials come from the other matrix. So again, not only is it important to put things together, but you also need to make sure that you label things in the same order. Because if you would mix up the order, you could still multiply them, and you would get an answer that means absolutely nothing. During August and September, production is increased by 40%. How could we write this as a matrix? Well, we can maybe even go back here, and if you haven't already, since we got a new answer, we'll take this answer and store it as matrix C. So now we have three matrices: matrix A, matrix B, and a matrix C. And if we want a 40% increase in production, and we call that matrix D, well, 40% increase would be multiplying by 1.4, but which matrix do we need to multiply 1.4 by? Okay, right, but how many budget presidential models were produced daily? It's just asking for daily, not the total. So just daily, you would take this and multiply it by matrix. Is it matrix C or matrix B? B. Because if we go back to matrix B, what do we want? We want per day along here, and we want budget, economy, executive, presidential there. So that has to be in the one that has that. If we look at our matrix, that's from matrix B here, which had those things. If they wanted to know how much per day of transistors, capacitors, connectors, and diodes, then you could take that and multiply 1.4 by matrix C. Someone got an answer for that already? 14, 16.8, 16.4, 15.4, and 9.8. Unlike the people, where before you have decimals and having an issue, for this, it could be possible that we could deal with a decimal. Maybe you just, it wasn't finished at the end of the day, but it could be finished the next day. Kind of makes sense. It takes 5 person-hours to produce a budget model. So this is how long it takes someone or a group of people. By person-hours, it could have 3 people working on it. But then if, depending on how much time they're working, total hours would be 5 total hours to build that, and so on. So now we got some more data here, and we need to make some more matrices. Okay? Now the matrix that we could make it this way: hours, and then budget, economy, executive, and presidential. Or we could put the hours here: budget, economy, executive, presidential. And depending on which one we do will allow us to do math with previous ones or not allow us to do math with previous ones. Okay? So just put the numbers in here. It's either 5, 7, 6, 7, 5, 7, 6, 7. So I haven't decided yet which of those is going to be helpful, but I know I can use one of those two, or I can make them both separate, and there might be advantages to both of those being separate in different ways. Okay? Determine the number of employees needed to maintain normal production schedule, assuming everyone works an average of 7 hours each day. So we'll do the normal, and then we're going to look at August and September. So we're going to find a total thing of hours. If we look back at our matrices, and first we're going to do the normal one. What are we actually trying to find? We're trying to find out how many hours per day are actually needed. We've got our matrices here that have hours with the different models. So we need to go back to here and find out, well, how many of those models are we making per day? Can you see that you have that in matrix B? So in order to use matrix B, okay, we would use this one. What letter are we on? Matrix E, as far as letters go. And in order for it to work out nicely, we're going to have to take matrix B, which was a 1 by 4, and multiply it by matrix E, which is a 4 by 1. Because then our 4s match up in the middle. And we're going to get a 1 by 1 as an answer. And the 1 from matrix B was per day. And the 1 from matrix E was hours. And that'll give us per day how many hours we need. And if we need that many hours per day and the average worker works 7 hours each day, we're going to take that number, divide it by 7, and that'll tell me how many employees I need for that day. Again, we can see that without matrices, you could figure this out. It's just a lot of data to deal with, and all of a sudden you're like getting overwhelmed and quitting. So what the matrix allows us to do is keep our data clean and together, and the matrix multiplication lets us do a bunch of calculations all at once, get an answer that we know what it means quickly, and then we're able to use that data further to find out other information. Someone calculate how many hours already? 249. Which, of course, if you divide that by 7, doesn't work out nicely. What does it come out to? 35 point, let's see if I can, 35.571428 repeated. There we go. What? Well, you're dividing by 7. Do you know the fun facts about 7s, your fractions? Do you have your, how many of your fractions to decimals do you have memorized? 1/2? 0.5, good, you got one of them. 1/3? 0.3 repeated. 1/4? 1/5? 0.2. And usually around 1/6 people start going, yeah. Does that someone know 1/6? 1/6 is 1.16 repeated. Okay? And then 1/7 is my favorite one. 0.142857 repeated. The nice thing about, the very interesting thing about 1/7 is if you know 1/7, you know 2/7, 3/7, 4/7, 5/7, 6/7. The only one you don't know is 7/7. Anyways. So 2/7, what's the second biggest number in there? The 2. 0.285714 repeated. Same order of the numbers. You just start with the number that it starts with. And then 3/7, the next biggest number is the 4, so it's 4.428571 repeated. And so on and so forth. Pretty cool. So what I was trying to do in my head, since I knew I was left with 4/7 there, is just trying to count, okay, well, of the numbers in there, which is the fourth one? And then once you said 5/7, then I knew it was 57142 repeated. From that, yes. I know, it helps you remember it too, right? 2 times 14 is 28, 2 times 28 is 56, and if you make a mistake, you get 57. So it works out really nicely for remembering it. Anyway, so where were we? We were figuring out something more important. We're dividing by 7 because this is how many hours you need in a day, and this is how many the average worker works. So it looks like you're going to have 35 and a half-time employee, but you work that half-time employee a little bit harder than half-time, but only pay him half-time to make as much money as possible. Yeah, that's right. And then if you wanted to do the same thing for August and September, well, then it's going to be not B, but what letter did we use for August and September? C? Was August, September our C matrix or our D matrix? D. Perfect. Look at this. D times E. And we could figure out that. Or you could just take our new matrix, which we could call F, and times it by 40%. Because if that's the number of hours you needed total for regular and you increased by 40%, well, you're going to have to increase your hours by 40% as well. And then increase your employees by 40% as well. Awesome. So what we're going to do is we are going to take the rest of class to work on some matrix multiplication ones.